Alright class, so we're going to begin with number 11 in part 3 of the review. And so I'm just going to bring you back to some basics, and we begin with a simple conversation of what do you do when you have like bases. What do you do to the exponents when you multiply them? And obviously the answer is you add them. So for number 11, you end up with 42, and this is x raised to the 3 over 4 plus 1 over 3. So you have to add these exponents, and so if you remember, 3 over 4 plus 1 over 3 requires a common denominator, and I called this in class crisscross applesauce. I don't know if you remember that, but basically 3 times 3 gives you 9, plus 4 times 1 gives you 4, and the product of the bottom values, the denominator, would end up being 12. So this will give you 13 over 12 for an exponent. The only one that matches that description would be that. So your final answer would be 42x to the 13 over 12. Okay? And this would be your answer for that one. Number 12. Number 12 is actually very easy. It looks a little ominous at first, but actually it's not. But it does require a few steps, and so let me show you the steps. So they start you off with the absolute value of x squared minus 4x minus 4, and that's equal to 8. So we're going to complete that with a negative 8 on this side. We start with that. Once you do that, you can actually get rid of the bars. And now what we're going to do is we're going to add 4 to all three sides of this equation. And so this gives us negative 4 equal to x squared minus 4 equal to 12. You can already see that I'm going to solve this two ways. I'm going to have to bring the negative 4 over, so I'm going to look at this side first, where I'm going to have x squared minus 4 plus 4, because I'm going to add that 4 back in here. Remember, this is a 4x in here. And I forgot to write it there as well. So that means that this factor is x minus 2, x minus 2. Right? And if I pull that back out, you can see that x equals 2 is one of my solutions. Now, going this way, I'm going to look at the expression going this way, and I'm going to subtract that 12 and bring it in here. And so now I have x squared minus 4x minus 12. And so my factors have to be a plus and a minus. So this has to be x minus 6 and x plus 2. And so therefore, x equal to 6, x equal to negative 2, and in this case, x equal to 2 are my solutions. So when I come over here at number 12, you can see that answer choice C would be the only logical one, matching these numbers to that. Number 13, solve the absolute value inequality other than null. Use interval notation to express the solution set and graph the solution set on a number line. Now we did these quite a bit in the last couple of days. And so for this one, the first thing I'm going to do is I'm going to subtract that 5. And I'm going to be left with the absolute value of 1 minus x over 2 is greater than or equal to 3. Right? Because I've subtracted the 5 on both sides. Now, to get rid of that inequality, I'm going to have to match that with a negative on the other side of the equation. If I subtract 1 on all three sides, notice that my next set, or my next equation, will read negative 4 greater than or equal to x over 2 greater than or equal to 2. And so when I get rid of the 2, I'm going to multiply by 2 on both sides of the equation, actually negative 2 on both sides of the equation. And that's going to flip my inequality, and I'll end up with negative 8 less than or equal to x less than or equal to negative 4. And so if you recall, I stated in our your work that you need to consider drawing a number line and splitting this off. So we know that we have, in this case, negative 8. Actually, this is positive 8. So negative 4 and positive 8. Remember, negative infinity sits here, positive infinity sits here. And so when you solve for this equation, you will find that they are both inclusive and they both extend over here after you test each of the test points. So remember, 0 is a test point. Over here you could use negative 5, and over here you could use, say, 9. And so plug it in. If it's true, it matches. Since that's a 2, you might want to use a 10 instead. And you might want to use a negative 6, because that way you can plug it in and it's a nice even number. And you can solve and prove that to be true. Alright, number 14. Same difference in this one. You would add the 12 to all three sides. So in this case, once I add the 12 to all three sides, I will end up with, in this case, 8 less than or equal to negative 4x less than, and again I'm adding that 12, so that's going to give me 16. And I'm going to divide by negative 4, so that means that the signs are going to flip. And so I will end up with negative 2 greater than or equal to x greater than negative 4. Okay, and so you want to test your points. Again, draw your number line. Here's, we start with negative 4, here's negative 2, we have positive infinity, negative infinity, and then use your test points. So in between these two, there's an easy number. We could use the 3 as a test point. And remember, I always said, always test the center first. Usually that's indicative. And guess what? Plug in that value, and you will find that this is your answer immediately. And again, test point here would be 0. You can already tell that 0 is not going to work, right? Because there's no way that negative 12 is going to be greater than negative 4. So that rules this out. Anything negative on this side is going to make that a larger. So let's test this theory. Let's plug in negative. Let's go with negative 5. If I plug in negative 5, I get negative 4 less than or equal to 20 minus 12 less than 4. And let's see if this is true for both. So in this case, you're going to get negative 4. Is that less than or equal to 20 minus 12, which is 8? That is true. And is 8 less than 4? That is false. If we prove that for the 3, now the 3 we plug in, or negative 3 we plug in, and we find that actually it is the solution for the inequality. Alright, and number 15, again with this one, I would consider foiling. I'm thinking 9 times 7, right? We know 9 times 7 will give us 63 as a product. And I know that 9 minus 7, or negative 9 plus 7 will give me the negative 2. So I'm looking at this and I'm thinking, okay, you must be x squared. And actually this is without u substitution. So you end up with x squared minus 9x squared plus 7. And so I can factor this further. This will end up being plus or minus 3, but this will end up giving me the x squared is equal to negative 7, therefore x is equal to plus or minus the square root of negative 7, which we know that is plus or minus I square root of 7. And so the only one that would give us that solution would be this one. With u substitution, however, remember u substitution, if you show when you show your work, you should know that u, so u is equal to, in this case, x squared. So we plug it in, we say u squared minus 2u minus 63 equals 0. You'll end up with the same answers anyway. So you'll still do u minus 9 and u plus 7. And then once you solve for u equal to 9 and u equal to negative 7, we then plug in the x squared. So x squared equals 9 and x squared equals negative 7. Solve for x, you get x equals plus or minus the square root of 9, which is 3. So plus or minus 3. And x equals, again, the same thing, where you end up with plus or minus I square root of 7. So there's no real difference in them. Alright, and this is the third part completed. Let me see if I can get to the fourth part without turning into a pumpkin, because it is 10:30 and geriatrics need their sleep. Call myself a geriatric. I can run circles around most people.